Alright guys, this is our last summer video. So one of the last things I want to talk to you about are creating box plots. And they're pretty easy to do because we just need to use our 5-number summary. So we already talked about before that our 5-number summary is our minimum, our Q1, our median, our Q3, and then our maximum. So to draw a box plot, we're going to start by making a box at Q1 and Q3. And we're going to use that then as our box in our box plot. We also need to draw a line at our median, wherever that is. And then finally we're going to draw our whiskers, which are our lines that extend to our min and our max. However, this is only a partial box plot because this doesn't include any outliers in it. If we have any outliers, we always notate them by using an asterisk, which is like our little star, right? So if our maximum value is an outlier, we're going to put a star or an asterisk there. Then our whisker doesn't go all the way out to that maximum, which is an outlier, but it goes to the next highest value that's not an outlier. So let's practice this. So let's use our New York data. So from our New York data, we know that our minimum value is 5. If we look, our Q1 is 15. Our median is 25. Our Q3 is 42.5. And our maximum is 85. Well, the first thing we want to do is check for outliers to see if we have any outliers. So remember, to check for outliers, we're going to use our 1.5 times IQR rule. So first thing we need to do is find our IQR. Our IQR, remember, is just our Q3 minus our Q1. And we're going to do 1.5 times that 42.5 minus that 15. Alright, and that's going to get us 41.25. Well, remember, we want to add and subtract that from our quartiles to find our fence. So we're going to do Q1 minus 41.25. So 15 minus 41.25. Well, that's going to get us a negative number. We can already see that. It gets us negative 26.25. Well, there's nothing below negative 26.25 because our minimum is only 5. So there's no outliers there. Well, then let's check our upper bound. We want to do our Q3 plus 41.25. So when we add our Q3, which is 42.5, plus our 41.25, and we'll get 84.25. Okay, so notice that our maximum is bigger than that 48.25, our upper fence. So that means that this 85 is an outlier, right? If we look back at our data, we'll notice it's the only outlier, right? It's just that one point at 85 because the next lowest value was below our 84.25. So now that we know this, we can make our box plot. The first thing we're going to want to do is make a number line, right? Make sure that it starts somewhere down by your minimum and goes all the way up to your maximum value. And you can count by whatever you want. So I'm going to start at 5, and I'm going to count by 5s. So 10, 15, 20, 25, 30, 35, 40, 45, 50, 60. You guys can probably do a better job of spreading your data out a little bit. Try and make your tick marks as even as possible. Well, now remember, the first thing we're going to want to do is put a mark at our Q1 and our Q3. So our Q1 was 15, and our Q3 was 42.5. So at 15 and at 42.5, I'm going to put a mark. Right, and I put mine above my number line, but if you want to put it on your number line, you're welcome to do that as well. And I'm going to make a box, so I'm going to connect those lines. Next, I want to put a line in my box at my median. Well, my median was 25. So at 25, I'm going to put my line. Okay, now the next thing I want to do is draw any outliers I had in. So we know we had an outlier at 85, so I'm going to put my asterisk at 85. Well, then remember, right, our whiskers only go to the non-outliers. So in the lower end, it's just going to be to my minimum value, because my minimum of 5 was not an outlier. But my maximum was an outlier, which means that I have to go to the next smallest value, which was 65 in my New York data. So my whisker will go out to the 65, so I'll just put a point there and then draw my whisker. Just like our other plots, we should make sure to remember labels. So we were talking about minutes. That's what all of these were for commuting. And we could give this a title, so New York commute times. And there's our box plot. Now let's talk about a measure of spread. Most often, we've always talked about range, right? Just take the largest value, subtract the smallest. But really, a better way of looking at spread is the standard deviation, right? Standard deviation and variance are used to measure how far data is from the mean. So let's do this by looking at the number of pets owned by 9 children. So if we want to find standard deviation, there's quite a few steps we need to do. The very first thing we need to do is find the mean. So find the mean of this data set. You should get a mean of 5. Alright, now you'll notice that we have this nice table to help us out. Our first thing we have to do is put all of our observations in. We call these our x sub i's, right? So each of our observations are already in our table for us. Next, we want to find our deviations. So we want to find our observation, our x sub I, minus our mean, right? We're finding how far is our data from the mean. So for our first data point, we would do 1 minus 5. So that's -4 away from our mean. Well, let's do it again. We're going to do it for all of them. So 3 minus 5 would get us -2. -1, -1, -1, 0, 2, 3, and 4. Okay, there are our deviations. Well, our next step is to find our squared deviations. So just like it implies, we're going to square our answers. So the thing to remember is that we're taking this -4, we're taking this -4 and we're squaring it, the whole thing, including that negative. So -4 times -4 becomes a positive 16. So our squared deviations should all be negative, or should all be positive, We should have no negatives at all. So -2 squared gets us a positive 4. Go ahead and square the rest of them. Alright. Now, the next thing we need to do is find the sum of these squared deviations. So we want to add all of them up to see what they add up to. They end up adding to 52. Okay, we're still not quite there. Now, we want to take that sum and we want to divide it by n minus 1, where n is just our number of observations. So we had 9 kids. So we're going to do 52 divided by 9 minus 1, or 52 divided by 8. And that gets us 6.5. All right, this 6.5 is our variance. So it's our squared standard deviation. Now, variance we don't use very often, but it will be useful a couple times, so don't forget about it. Really, though, what we want is standard deviation. So to find standard deviation, we're going to take our variance of 6.5 and we're going to square root it. Once we square root that 6.5, then we have our standard deviation, which in this case is 2.55. Right? That tells us that for these 9 children, right, our mean was 5, so on average they own 5 pets, but that varies by 2.55 pets. With standard deviation, we can find the average squared deviations by adding all the squared deviations and dividing by n minus 1, right? Remember, this is our variance, right? But the reason we have to square root is because, remember, we squared all the deviations in our units. So our units are like pets squared, which is not helpful. So that's why I have to square root it again to get back to just a unit of pets instead of pets squared, and that's what gets us standard deviation.